Okay, so in this video for homework 6, we'll be defining the differential equation y prime equal to y times y minus 1 times y minus 3. Yeah, okay. So for this equation, we'll find the critical solutions and we'll determine the stability of those solutions, and then we will use those critical solutions and their stability to graph the directional field for the equation. Okay, so let's start out. What is a directional field? So a directional field given by any first order linear differential equation, and we'll set it with respect to t and y, is the set of y prime for any given unique solutions t and y. Okay, so we would graph this as, for these lines, we would have our y-axis in the red, and then we would have our t-axis for orange, okay? And at any given point on this graph, let's say right here, okay, we would have a specific slope, a tangent line that we could put there to denote the slope of the line, okay? So we'll start out and now we need to discuss our critical points. So what are critical points? Critical points happen whenever y prime is equal to 0, okay? So for our equation, we can see that y prime is equal to 0 when y is equal to 0, 1, and 3. Okay, so our critical solutions happen when y prime is equal to 0, and we can plot this out on this line, okay? So we know because it's crossing 0 on the line, we are having some kind of sign change in this equation, okay? So that means that we're going from a negative slope to a positive slope, or a positive slope to a negative slope, okay? So we can graph this, and we have y equals 0, 1, and 3, and we can plug in values on each of these intervals to check out the sign value. So right here we can plug in y equals -1, and we'll have -1, -2, and -4. So we'll have 3 negative values, and that will give us a negative value for this interval, okay? So we know that all values on negative infinity to 0 of y will have negative slopes, okay? So that means that y will be decreasing on this interval, okay? And then on the interval of 0 to 1 for y, we can plug in 0.5, and we'll have 0.5, and -0.5, and -2.5. So we'll have a plus, negative, and a negative. This will make a plus value for our y prime. So we know that on the interval of 0 to 1 for y, we will have an increasing slope. We can do the same for the interval of 1 to 3 and 3 to infinity. So for this one, we can use 2. We'll have 2, 1, and -1. This will give us a negative y prime value. And then for 3 to infinity, we can use 4. So we can have 4, 3, and then we will have 1. So this will be plus, plus, plus. We'll have a positive interval, okay? So what does this tell us? This tells us that for this interval, for these intervals, okay, on negative infinity, we'll have decreasing, increasing, decreasing, increasing. And we can plot this. We can plot this using these critical solutions. Okay, so you can see right here, we're just moving this over, okay? So y prime is negative, we have decreasing y, okay? And we can see that if we were to graph this y with respect to t, into the variable t, okay, we would have y moving away from 0 on both sides. So this is how we determine an unstable solution. A stable solution has integral curves on the directional field converge on it. It has converging values. So like we can see, like with 1, y equals 1, the values of y will converge on this value. So it is a stable solution. Meanwhile, the values of y will diverge from y equals 0, and they will diverge from y equals 3. These are unstable solutions, okay? And that is with t going into infinity. So we can write it on this directional field right here, okay? So I can draw it out. So let's say for, this is our y equals 0, okay? So let's say we have some given point right here, okay? And this is within, let's assume right now that this is within our directional field. So if we watch this point, we know that it has a decreasing slope. So as it goes to t in positive infinity, so as it goes to t equal to positive infinity, or as t goes to positive infinity, y will be decreasing and it'll diverge from 0. Okay, we know the same will happen over here, and we know that it'll go away from 0 and towards 1. So we'll see a y value going near but not at y equals 1. Okay, on the interval from y equals 1 to 3, we'll see the same thing. So let's say we're starting right here. Okay, this is an arbitrary y value. Okay, we know we're going to converge onto this value of 1 since this is a stable solution. We can also look at it the other way. So if we're going towards negative, values of t, as t goes towards negative infinity, we can see that this reverses. So the value of y equals 1 will be unstable. The values of y equals 3 and the values of y equals 0 will be stable if we go towards negative infinity. So we can use this and we can graph our directional field, okay? So knowing unique solutions, as we had beforehand, unique solutions for t and y, we can graph our directional field knowing individual tangent slopes, okay? So we know at -1, our slope of y will be -8. We can plug this into this equation, -1, -2, and -4, okay? And this will give us -8. And we can do this and plug in multiple points, and we can just get an idea of what this graph looks like. And this will be our general directional field for y prime, okay? And if we want to take this, we can plug this into technology and get similar results, okay? So this is our original equation, and this would be our y-axis would be y prime. So this would be y prime, okay? And then this would be our values of y right here. And then if we move this onto a directional field, we will get the same thing. Okay, so right here we'll see, just as we said before, as we found out, the values will diverge on the interval of y3 to infinity. They will diverge on the intervals of 0 to negative infinity, okay? And on the intervals 0 to 1 and 1 to 3, they will converge on the value of y equals 1.